All right, the topic for this video is going to be the Pythagorean theorem and classifying triangles. Our essential question we're going to be looking at here, the thing we're going to try to answer by the end of this video, is how is the Pythagorean theorem used? All right, little background. Another ancient mathematician, we've been talking about Euclid a lot in these videos, but another ancient mathematician named Pythagoras discovered and proved a famous theorem relating the three sides of a right triangle known as the Pythagorean theorem. What is the Pythagorean theorem? It says if a triangle is right, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. All right, so what does that look like? Well, if we've got ourselves a right triangle here, the two sides that make the right angle are known as the legs, and the hypotenuse is, of course, the longest side. That is the side that is opposite the right angle. And so if we go ahead and call the legs A and B, the hypotenuse is C. The hypotenuse is, of course, that longest side, and the Pythagorean theorem says a squared plus b squared equals c squared. So the sum of the squares of the lengths of the legs, so the legs squared added together, is equal to the square of the length of the hypotenuse. And that is our c. So a squared plus b squared equals c squared. Now, sometimes when we're talking about the Pythagorean theorem, we get some special numbers that end up working out, and those are called Pythagorean triples. A Pythagorean triple is a set of whole numbers that satisfies the Pythagorean theorem. So what do I mean by that? One of the famous ones is 3 squared, 4 squared, and 5 squared. So legs of 3 and 4 with a hypotenuse of 5, that works. 3 squared plus 4 squared equals 5 squared. Another famous one would be 5 squared plus 12 squared equals 13 squared. 5, 12, and 13 works out. Another one that you might see is 8, 15, and 17. And of course, these are, the yellow ones are the lengths of the legs, right? We could have a leg of 8 and 15 and a hypotenuse of 17. And then another one would be 7, 24, and 25. That's another good one. Now, an interesting thing that also works, multiples of any of those ones that we wrote down. So take 3, 4, and 5, for example. I could multiply all of those by any sort of scale factor, and it'll still work as a Pythagorean triple. So imagine that I multiply all the sides by 2. Then 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So 6, 8, 10 would work. So any of those could be multiplied by some scale factor and create a similar triangle, and it would still be a right triangle. Okay, so let's try using the Pythagorean theorem here. So example 1 here says solve for x and determine if the right triangle is a Pythagorean triple. Okay, so our legs here are the 9 and the 12. Our hypotenuse is the x. So our Pythagorean theorem says a squared plus b squared equals c squared. So in this case, that would be 9 squared plus 12 squared equals x squared. 9 squared is 81. 12 squared is 144. 81 plus 144 is going to be, what would that be? 81 plus 144 is 225. And then let's take the square root of both sides to figure out what x is. And we are going to get, that is a perfect square. That is going to be 15. So is that a Pythagorean triple? Yeah, we got 3 whole numbers. So that is a Pythagorean triple. 9, 12, and 15, and that is actually the 3, 4, 5 right triangle, all multiplied by 3. Right, 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. So that is the 3, 4, 5 right triangle. All right, what do we got here? Solve for x, determine if the right triangle is Pythagorean triple. Okay, so this time our legs are x and 6. Our hypotenuse is 8. So let's set that up. A squared plus b squared equals c squared. That would be x squared plus 6 squared equals 8 squared. 6 squared is 36. 8 squared is 64. Let's subtract that 36 this time. 64 minus 36 is 28. We take the square root of both sides. 28 is not a perfect square. So I'm going to have to simplify this. And how could I do that? I could do a 4 times 7. 4 gives me a pair of 2's. So the 2 comes outside, the 7 stays inside. So x is 2 square root 7. And since that's not a whole number, this is not a Pythagorean triple. Okay, let's keep moving. So let's go to the inside there and check out example 3. Once again, we got Pythagorean triple. All right, so those are my legs. This is my hypotenuse. So a squared plus b squared equals c squared. I'm looking at x squared plus 15 squared equals 25 squared. 15 squared is 225. 25 squared is 625. When I go to subtract the 225 to get the x squared by itself, I'm going to be left with 400. And taking the square root of 400, 400 is a perfect square. So that's going to be 20. So x is 20. So is this a Pythagorean triple? Yes, it is, since we got a whole number. And what kind of Pythagorean triple is this? That is another 3, 4, 5. This time, you might have noticed that everything was multiplied by 5. 3 times 5 is 15, 4 times 5 is 20, 5 times 5 is 25. Okay, so we can see that the 3, 4, 5 is pretty common. Example 4, Adriana is buying a ladder to reach the top of her 20-foot tall house. There's a flower bed that prohibits her from placing the base of the ladder any closer than 4 feet. How tall of a ladder should she buy? Draw a picture and run your answer to the nearest foot. Okay, let me try to draw a picture here. So we got a house. This is my house. And we're trying to get a ladder. They can reach the top of the house. And there's this flower bed. So our flower bed's right here. It's a really bad flower, but hopefully you see what I'm talking about there. And what we end up with here is a right triangle where the hypotenuse is our ladder, and then the house and the flower bed are the legs. That's kind of what we're dealing with here. We know that the house is 20 feet tall. So that's the 20. And we know that the ladder can't be any closer than 4 feet because of that flower bed. That flower bed is 4 feet. So we want to figure out how long should this ladder be. So that's going to be my x. So now that I've got my picture, I know that my a and my b, my legs there, are the 4 squared and the 20 squared. And I want to know how long that ladder needs to be. I want to know what that x is. So 4 squared is 16, 20 squared is 400. 16 plus 400 is 416. And we need to take the square root of that. Now, it does say round your answer to the nearest foot, so we don't need to bother simplifying this thing. We just need to actually take the square root of 416, and that is 4. Now, 20.4 is closer to 20 than it is to 21, but if we buy a 20-foot ladder, that's not going to be long enough, right? Because we need it to be over 20. So we're going to round up to 21 feet here. We need at least a 21-foot ladder for it to actually reach the top of the roof. If we could buy a fractional ladder, we would buy 20.4, but they don't do that. You can't go into Home Depot and find a 21 or 20.4 foot ladder. So we gotta get at least 21 feet. Okay, so Pythagorean theorem, we're gonna take a break from that for a second. Little reminder about an old thing called the triangle inequality theorem. Triangle inequality theorem says that the sum of the lengths of two sides of a triangle must be greater than the third side. So here's what we're talking about here. When you've got a triangle, obviously triangles have 3 sides. So let's just say we got A, B, and C. What the triangle inequality theorem says is in order for a triangle to be formed, in order to make a triangle out of 3 lengths of sides, A plus B has to be bigger than C. B plus C has to be bigger than A, and A plus C has to be bigger than B. Any 2 of the sides added together has to be greater than the third side. So like on example 5 down here, it says determine if the sets of side lengths can form a triangle. 5 and 5 added together is 10. And 10 is not greater than 12, right? Those 2 sides added together is not bigger than the third side. So this does not make a triangle. We cannot make a triangle out of a set of sides of 5, 5, and 12. For B here, 3 plus 4 is 7, and 7 is bigger than 5. So that is a triangle. That can be a triangle. For C, 10 and 11 is 21. 21, let me write that a little bit different there. 10 plus 11 is 21. 21 is not greater than 21. So this is not a triangle. And then for D, if I add it together 10 and 10, I get 20. 20 is bigger than the third side, which is 10. So that would be a triangle. So for simplicity's sake, just take the 2 smallest sides, take A and B, the 2 smaller sides, add them together, and make sure that they are bigger than the biggest side. If it's not bigger, it's not going to make a triangle. Like we saw on A here, right? 10 was not bigger than 12, not a triangle. We saw over here, 21 is not bigger than 21, so not a triangle. Being equal to each other is not enough. We are checking to make sure that it is bigger. Otherwise, we cannot make a triangle. Okay, last bit here. So this is the converse of the Pythagorean theorem. It says Pythagoras also proved that the converse of his famous theorem was also true. Converse of the Pythagorean theorem says if the sum of the squares of the lengths if the sum of the squares of the lengths of the legs, or we'll just say the smaller sides, is equal to the square of the length of the longest side, then the triangle is right. Okay? So what that is going to essentially say for us here is three different things. So if a squared plus b squared is equal to c squared, that means that it is right, a right triangle. And then there's going to be two kind of extensions also. If a squared plus b squared is greater than c squared, it is acute. And if a squared plus b squared is less than c squared, it is obtuse. Okay, so three different things here. If a squared plus b squared is equal to c squared, it's right. If the a squared plus b squared side's bigger, it's acute. And if the c squared side is bigger, then it is obtuse. All right, so those are going to be the three different ways that we can use it in order to figure out what kind of triangle it is making. Because if we remember, the original Pythagorean theorem said that if it's right, then a squared plus b squared is equal to c squared. Converse, when we flip the hypothesis and conclusion, says that if a squared plus b squared is equal to c squared, then it's right. But also, we can use that to kind of justify if it's acute or obtuse as well. So down here, it says determine if the sets of the in the triangle, and if so, classify the triangle. Okay. So here's what we're looking at. First of all, let's go ahead and make sure that we can even make a triangle out of this. Let's use the triangle inequality theorem to make sure we can make a triangle. We got to make sure that this thing is a triangle first. So 5 plus 6 is 11, and 11 is greater than 10. So cool. That's what we did with the triangle inequality theorem down here to make sure that we could make a triangle, right? So now we know that that is a triangle. So now what we're going to do, we're going to do 5 squared plus 6 squared, and we're going to compare that to 10 squared. 5 squared is 25, 6 squared is 36, 10 squared is 100. 25 plus 36 is 61. So 61 is less than 100. So if a squared plus b squared is less than c squared, that was obtuse. So that means this thing was an obtuse triangle. So notice what we did. First, we checked to make sure it was a triangle. Then we did the converse of the Pythagorean theorem to see what kind of triangle it was. Okay, next one. So 30 plus 40 is 70. 70 is bigger than 50, which means, cool, it is a triangle, so we'll move on and figure out what kind of triangle it is. So now we'll do 30 squared plus 40 squared, and we're going to compare that to 50 squared. That's 900 plus 1600 and 2500. 900 plus 1600 is actually 2500. So 2500 is equal to 2500. So if a squared plus b squared is equal to c squared, that means it's a right. All right, let's move on to C. So C, we've got 6 and 8. So 6 plus 8 is 14. 14 is not bigger than 14. So we just stop everything and we say this is not even a triangle. We are not going to move forward and see how a squared plus b squared relates to c squared because that thing's not even a triangle. We're done right there. And then D. So for D, we'll do 7 plus 8. Compare that to 9. 7 plus 8 is 15. 15's bigger than 9. So that is a triangle. So that's a check right there. Now let's see what kind of triangle it is. We're going to do 7 squared plus 8 squared. Compare that to 9 squared. That's 49 plus 64 compared to 81. 49 and 64 is 113. 113 is greater than 81. So if a squared plus b squared is bigger than c squared, that was an acute triangle. All right. Cool. What does example 7 say? It says 3 students are convinced that side lengths of 4.5 inches, 7.5 inches, and 6 inches construct a right triangle. Are they correct? And if so, which side is the hypotenuse? Okay, so how do we check to see if it is a right triangle? Well, let's write those down here. We got 4.5, 7.5. Actually, let's put 6 next, because 7.5 is the biggest side. So first of all, let's make sure that we can even make a triangle out of this. Make sure that these students aren't crazy. 4.5 and 6 give me 10.5. 10.5 is bigger than 7.5. So they are correct that you can make a triangle out of that. Now to see if it's a right triangle, we need to see if 4.5 squared plus 6 squared is equal to 7.5 squared, right? This needs to be equal to each other if this thing's going to be a right triangle. 4.5 squared. What on earth is that? Let's find out here. 4.5 squared. That is 20.25. 6 squared is 36. And then 7.5 squared is 56.25. Now if I add those together, oh, check that out. That is 56.25. So 56.25 is equal to 56.25. So a squared plus b squared is in fact equal to c squared. So yes. This is a right triangle. And that means that 7.5 is the hypotenuse, because that's the biggest side. That was our C. Good job, students. They got it right there. All right. Hopefully that went well. And why don't you guys try out a few problems here? So you've got the your turn problems to try out. You've got 3 Pythagorean theorem type questions, and then 3 where you're going to have to classify things. So give those a shot, and then come back and check this when you are ready to see how you did. All right, hopefully that went well. For this one, you should have done 9 squared plus x squared equals 15 squared. That was 81. It's equal to 15, or not 15 squared, 225. Subtracting that should have given you, what would that have been? 144. And the square root of that was 12. That was a little 3, 4, 5 right triangle right there. 8, 10, and x, that should have been x, 8 squared plus 10 squared equals x squared. That's 64 plus 100. That's 164. Take the square root of that. How can we simplify that? I guess that's 4 and 41. 41 doesn't do anything, but 4 gives us a pair of 2's. So I would say that x is 2 square root 41. If you simplified it, that is what you would have gotten. Okay. Number 3 says a rectangular garden. So has sides of 6 and 8. Find the length of the diagonal. Now the diagonal goes from corner to corner. Now, hopefully you remember that rectangles have right angles, so this makes a little right triangle. We want to know that. So I'm going to do 6 squared plus 8 squared equals x squared. 36 plus 64 is equal to x squared. We get 100 for x squared, which means we take the square root of that and we get 10. The length of the diagonal is 10. Determine if the sets of side lengths can form a triangle, and if so, classify the triangle. Okay, 10 plus 13 is 23. 23 is greater than 20, so it is a right triangle. Now we'll do 10 squared plus 13 squared. Compare that to 20 squared. It's 100 plus 169. 20 squared is 400. So that's 269. That is less than 400. So if a squared plus b squared is less than c squared, then that is an obtuse triangle. What about this one here? Well, right away, 4 plus 5 is 9. 9 is not bigger than 12. This is not a triangle. We don't need to classify it because it's not even a triangle. This one, 27 plus 36 is 63. 63 is bigger than 45, so that is a triangle. Now we're going to do 27 squared plus 36 squared compared to 45 squared. 27 squared is 729. 36 squared is 1296. And then 45 squared is 2025. So let's add those together. 729 plus 1296. Ooh, that is 2025. So those are equal. And if those are equal, that is a right triangle. All right, hopefully that went well for y'all, and that's going to wrap up this video.